Halo CE holds a massive place in my heart due to childhood nostalgia and it being the only video game my brother and I were allowed to play, and we were only allowed to play on our birthdays when we were younger. My parents really didn't like video games. However, I really liked them and still do, though my like goes beyond playing them and I've become enthralled with how they work. So I have ended up spending a lot of my life working on a game engine in C, and more recently making games in Godot with both C++ and GD script. With the recent AI boom, I've become repulsed by the term AI. Whenever I've heard anyone talking about AI, they almost always mean generative AI, such as LLMs and Stable Diffusion, which I'm really opposed to. I won't get into why here though. Luckily, this artificial intelligence class is not focused on generative AI, and has concepts that apply to game AI, which is handy for what I want to make. As part of this class, we gotta choose a project to work on, which culminates in a video, which is what this video is. For my project, I chose to try and make some AI similar to the AI in Halo CE, because I think it is the paragon of game AI. By the end of this project, I wasn't able to reach anywhere near the heights of Halo, but I was able to learn a lot about how their AI functioned and implement some of the basics of that kind of AI system. I started out with a blank project and named it Umbra because I really like that word. I didn't think too hard about it. It's a good name. Anyways, I have a library called HerbGlitch, which I've been working on for some time. It uses Godot C++ and has some useful nodes, so I don't have to write systems like a player controller from scratch. I also decided to copy the start menu from a different project I had on hand, as the menu was mostly boilerplate. From there, I created my usual game script that loads in a selected map and created a map called Lobby. Now, I'm not good at map design, and by that I mean I'm really bad at map design. So knowing this, I threw together some shapes on a flat ground and hoped it would work well enough for terrain that my AI could use. Usually I work on multiplayer projects, but as this project was time sensitive, I decided to add the player directly to the scene instead of spawning them. It felt really weird to do. That night I couldn't sleep because I was thinking about lore. For me, lore is really important when making a game, so I know what to call things, and it gives me a fair bit of motivation. The lore for this project is very simple. Basically, you're on a planet that is shrouded in shadow, and you're trying to make it to the Umbra of the shadow. The creatures are all translucent in a way, not sure why, I just thought it sounded cool. With that very in-depth lore in hand, I decided to name my first enemy Glass, and thought through how I wanted them to behave. In the Halo CE video linked below that goes through how they worked on their AI, they had a few inputs the AI could use. So for my AI, I decided I wanted the inputs to be vision, sound, which is hearing and them being able to signal each other, animation, which would signal the state or emotion the enemy was going into, and memory used by the AI. And the ones I thought most important to implement would be vision and animations. I started by adding a simple vision cone that used a raycast to check for the player. I wanted to implement this quickly, so I just followed a tutorial. It's linked below. Basically, every few milliseconds the enemy will check if there is a player in the vision cone. If there is, it will then point the raycast at the player to see if it can actually see the player or if there's something in the way. It's pretty simple. From there, I wanted animations, and the character I was using was a spider-bot thing, so I thought adding inverse kinematics would be a good idea. The only hitch was I don't really know inverse kinematics. Luckily, there was a tutorial linked below on inverse kinematics that worked mostly for what I wanted. I did have to change a few things because my model was rigged a bit differently, and I tried for a few hours to fix the rig in Blender, but I just couldn't figure it out. Though luckily, in Godot, I was able to tweak some settings and I got the spider-bot moving with the arrow keys and its legs following along semi-decently. I think it's pretty cute, actually, what I got. Funnily enough, I didn't end up using this character as the animations only really worked for moving and wouldn't be able to show defensiveness or rage. One of the things Halo CE does really well is have animations that match the state of the enemy, which clearly signals to the player what it's going to do. I wanted something like this, but as I've said before, my design skills are horrifying at best. So I looked for a character pack. I found a few, but the ones I liked the most cost money or weren't rigged. I'm totally down to pay for assets, but in this case I wanted the project to be open source, meaning all of the assets would have to be available to whomever checks it out. Because of that, I couldn't include paid assets, and the assets I found that I thought would work didn't mesh well with the animation library I was going to use. So I ended up just using the prototype model from the animation library and changed the model's colors for the enemy type. By this point, the glass enemy reminded me more of the Flood than a grunt, so I decided to add 2 new enemy types, Calcite and Spinal. I'm probably saying those wrongs, but I got their names from Wikipedia under transparent materials. I wanted to keep their names in line with the lore that I had in mind. Running low on time, I decided that the most important next step would be being able to damage the enemy to have them react in different ways, so I added a pistol and a sticky grenade. The grenade wasn't supposed to be sticky, but being short on time, I decided sticking was probably easier to implement than friction when the grenade collides with the ground. During testing, it would just roll and just go. For the grenades, I followed a particle tutorial for the explosion because I didn't know the particle system very well. The tutorial is linked below. With weapons implemented, I realized that the current level would have been really hard to add position markers to, as there are so many obstacles there for defensive points, so I decided to graybox a cafeteria. I looked up schematics of a cafeteria and used CSG boxes to try matching that blueprint, and I think I made this level feel much more like an actual level. Still not good, but serviceable. I was then able to add the position markers, though because of how Godot handles resources, I did have to fiddle around a bit to get the markers showing the right editor colors. Like I said before, for the AI I wanted to have hearing, vision, health, notifications, both visual and audio, and memory all play a role in how they behaved. Though due to the time constraints, I ended up only being able to add vision, health, visual notifications, and memory of the player. I started out by writing down how I wanted the AI controller to behave. All the notes are in the repository under actor.md, but as a simple overview, they patrol between different position markers that you manually place in the game. They just choose, or are supposed to choose, the closest marker that isn't the current one they are on, though this ended up being a bit buggy. I wanted to get more complex with how the markers were used, like setting specific IDs so the enemies could have a set ID and then go to only specific points, but just ended up not having the time for that. They also, based on type, can go into a defensive state where the dancing animation plays. I couldn't find anything else that would work for this animation, and who knows, dancing might cause your enemy to stop shooting and join in. And they run towards the nearest marker that has the defense weight of 0. Lastly, they have a panic state where after taking a certain amount of damage, it is based on the enemy type, they will run away from where they last remembered the player being, then they will scan for the player again. It's really simple, they just turn around looking for the player, and if they see the player, they will go back into their main panic state. While this project didn't hit the vision I had in my head, I'm not disappointed by what I was able to achieve in the time I had to achieve it. Sadly, I wasn't able to get anywhere near what Halo CE has, but I was able to think through how I personally would implement that system, and I was able to implement a decent chunk of my vision. If I did a project like this again, I would start out with the grayboxing a level and using a top-down blueprint of the area I'm trying to make. Being able to see a serviceable map really helped me think through how I wanted to implement things. From there, I would probably just use a Mixamo animations and animated character so I could choose the animations I'd want to use instead of having to stick with what is in the animation library and dancing for defense. Though, if I had enough time, I'd probably actually just work on the animations myself, because animating the gun in Godot wasn't that bad and I want to learn more Blender. From there, most of the hard stuff would be out of the way and I could spend more time in working on the AI itself. Thank you for watching this video. While making this video, I found some new ways to record and work on making videos that I hope will help me upload more frequently. The next video I'm planning on making is a tutorial on setting up Godot C++, as there aren't really many on YouTube. I have links for Matrix and Discord in the description if you want to talk about programming or would like help with programming related things. Take care and have a wonderful day. I realized when editing that I did say that this project would be open source, but I never said that it's linked in the description. So if you want to check out this project, it is linked in the description, though libneoglitch, which is the add-on, does need to be compiled, or you need to grab the release version off of GitLab and put that into that add-ons folder where libneoglitch, that submodule, is, in order for it to work, if you want to mess around and play around with what I've done.